Okay, welcome back to exploring quadratic functions. I know we took a day off to explore transformations of linear functions, and now we're back to investigating different things about quadratics. The last quadratic lesson that we had, we were looking at a quadratic equation in vertex form, and we were finding our vertex and our axis of symmetry. Well, today we're going to explore a quadratic equation in the standard form. The standard form is the ax squared plus bx plus c, and we're still, given this form, going to find our vertex. That's the point where our parabola turns around and heads the other direction, and our axis of symmetry. That's the vertical line that cuts the graph symmetrically in half and goes straight through the vertex. So the good news is, even though this isn't quite as simple as the vertex form, we are able to use an equation to find the axis of symmetry. So let's go ahead and just make sure you know that's our axis of symmetry. And the equation that we can use, or the formula that we can use to find the axis of symmetry, is x equals negative b over 2a. Now if you're thinking to yourself, yep, I'll never remember that. Okay, the good news is on the STAR test, on the district checkpoints, on tests, they're on the reference material. It gives you the formula for the axis of symmetry. So you will be able to look at your reference material and find it. The other thing I just wanted to point out to bring back to your memory is in the standard form, this plus c gives us our y-intercept. Our y-intercept is 0, c. So just bringing that back in, getting it all ahead. So let's look at problem number 1, practice number 1. It wants us to find the axis of symmetry and the vertex. So let's go ahead and make this big so we have easier to see. So we're going to start, and to find our axis of symmetry, we do need to remember that we have an a value, our b value, and our c value. So if we write it out, we got a equals 1, our b, our coefficient to the x, is negative 10, and our c in this case is 2. And we're going to need some of that for the axis of symmetry formula. So to find our axis of symmetry, I'm just going to abbreviate it like that. I'm going to do x equals negative b. So negative, and then my b is negative 10 over 2a. So 2, and then my a is 1. Okay, so let's see how that pans out. Negative times negative gives me a positive 10. 2 times 1 gives me 2. So my axis of symmetry is x equals 5. So that x equals 5 means that that is also the x value of my vertex. So if I know that this is the x value of my vertex, I can plug this in as x to my original quadratic function and solve it for y, and I will have the y value of my vertex. So let's go ahead and do that now. So we've got y equals, then instead of x, we're going to put a 5. So 5 squared minus 10, and instead of x, we're going to put a 5 again, plus 2. Okay, so then as we start simplifying it, that equals 25 minus 50 plus 2, and that whole thing equals negative 23. So my vertex is 5, negative 23. So I'm just using my formula, my axis of symmetry formula, to find my x value of the vertex, and then I'm plugging it in to get my y value of the vertex. Okay, so I want you to do number 2 on your own. Pause your video while you do it and then check back for the explanation. Okay, so I just identified my A, B, and C, plugged in my axis of symmetry formula to come out with x equals 2 as my axis of symmetry. Knowing that that's the x value of my vertex, I plugged it in and I found my y value to be 16. Okay, number 3 and 4, you're following the same process again, finding your axis of symmetry and vertex. I want you to do 3 and 4 on your own, pause your video, do the work, and then check back for the answers. Okay, take a moment to check your answers on number 3 and number 4. Pause your video if you need to double check that you got them correct. And now let's move on to number 5. So number 5, it wants us to graph the function and describe the domain and range. The way we're going to graph the function is we need to find our vertex and our axis of symmetry, just like we did. And then we're going to need to find, well, we're going to use our y-intercept, which is the c value of our equation for our third point. Then we can graph it, and then we'll write our domain and range. So I want you to pause your video and work through number 5 and number 6 on your own, and then check back for the solution and the final explanation. Okay, so take a moment to check over all your work. Probably the only little bit of a tricky thing was to know that once you graphed your vertex and axis of symmetry and you found your y-intercept, then you use the distance to your axis of symmetry to graph your other point. That's the only thing we really didn't discuss before I sent you off to do these. Just make sure you got all the answers correct.